Hello everyone. So in this video, we're going to quickly reviewing some object-oriented concepts and also a little bit of UML diagram. So since Java is an object-oriented language, it's important for us to know how to program in an object-oriented way. And in order to do that, we need to know some of the object-oriented concepts that are going to help us a lot to make our program and our design as flexible as possible, as easy to change, that's the important part, as possible, as easy to understand as possible, and as easy to test as possible. So we're going to review the concepts of objects, classes, inheritance, interfaces, and packages. Just real quick, and also show you for each of them how we're going to draw the UML diagram, and I'm also going to show you the UML diagram for each of them. So the first question is, what is an object, right? So objects are basically the key and the most important part of the object-oriented technology, right? So we want to think as objects. So basically, the more conventional way of thinking was thinking everything as procedures or methods. And then we decided to change that view to solve the problem that they more look like a problems that we can solve use the kind of natural way, like we would think about everything around us. Everything is object, and these objects are going to have their own characteristics, which we call them state properties, attributes, variables, or whatever you want to call them. There are different names for them, but mainly they're properties or fields. Mainly we use data field when we're talking about the state of the objects. And also they have behaviors. So we call those behaviors our methods, functions, um, or like some sort of names like that. So, but they're basically showing some sort of actions that is specific to that particular object. So whenever you think about that objects, you think about that particular behavior in that objects too. So when I think about a student, I know student have name, have ID, right? So that's the main things come to my mind. And student is an object. So the name and ID is the state of this student, each student as a template, like, when you think overall about the students, they're all going to have a name and they're all going to have some sort of ID. And they have a specific behaviors, right? They have to take courses, right? They have to register the courses, and they have to basically, maybe they can drop the course, maybe they can register in multiple courses, stuff like that. So these are going to be the main things you have to think about. So think as everything as an object, everything around us as an object. Be able to identify objects and be able to think as object. It's very important. So this is the main things in object oriented that you have to remember. If you be able to do that, then you're going to make each individual object and its state and its behavior in a separate bundle. And this is going to give us some benefits. So for example, this is going to make our code modular. So modularity is going to be very important to make the codes maintainable, easier to understand, because everything, when you're looking for something, there is a logical constructions there. So you can easily find what you're looking for. It's exactly like what architectures do, right? When architecture designing a house, for example, when they're doing it in a very logical way. So everything related to the kitchen is going to be in an area that's related to the kitchen, right? So if you're looking for a spoon, for example, you do not need to go to a closet in a room to look for a spoon, because there's a logical order and logical structure available. So same thing should happen inside our code. Should be easy to understand where we go, and where should we go to find what we want. Because again, the codes are no longer small little codes that only one individual person is going to look and work with it. The codes are becoming huge, millions of line of codes in multiple different years, and lots of different group of people going to work on them. So they definitely need to be organized. So modularity is going to help a lot. Information hiding is important because we don't want anybody come and change our code. Like, so make our code more secure by uh, basically make those information hiding concepts into it. The protecting the data by hiding them from whoever not supposed to see it, right? So each object is going to only knows about or its own information, and it's going to protect them. You cannot go ahead and change those information without basically without having internal knowledge. And internal knowledge only going to be available to particular classes that their job is, to make changes or to do what they have to supposed to do. So that makes it more. That makes our code more also. Uh, as far as like also even easier to understand, because now when you want to do something or you're looking for particular data, you know where to go and who's going to be responsible to give you those data. You just don't have to go everywhere. And also people, and you basically separate things from in your model from outside of the board. So that's going to really make implementation easier and harder to make unnecessary changes, unneeded changes, even even randomly, right? So because you're protecting those things, and then it's become reusable, right? Because now you have these modules that you're each of them is separate from the other. They're working independently, and that way you're not going to accidentally change anything because everything has its own protection. And you can use this module again in another completely different scenario, which have the similarity, and this module can be useful there. So when you be able to reuse them, reusing the same code, that's actually important in math production, right? Because we're basically trying to do math production as far as coding, right? We don't want to keep writing the same code over and over and over again. If we write it one time and we do it very good, then we can use it multiple times, kind of like a Lego, like the concepts of Lego. Now it's coming by, if you write in a modular way, right? So you can now use this piece of Lego, this piece of module again and again and again in different structures you're trying to build. So pluggability and debugging also become easier because since it's modular, you can pick one module, change it with another module, and so we can plug in and plug basically plug in different objects. Without making a lot of changes, right? So we're trying to minimize the amount of work, the amount of change, and so all of these, if you're doing it correctly, it's going to give us tremendous benefit if you use object-oriented concept correctly. If you're not using it correctly, then you're going to create a chaos, which is it's basically make it really hard to understand, and so not really worth it anymore. So that's why it's important to understand why we have objects, what we're doing with these objects, and how we're using this in different classes, and then how these classes are going to talk to each other. And so basically coming as looking at everything as a design perspective first in an abstract way, then go to the details of them whenever it's needed. So it's very important, and you're going to keep seeing that in software engineering, that we're trying to kind of look back again and look back and look everything in a very overview, very abstract way. Try to understand the structure, try to understand the pieces, in an abstract way, how they connect to each other. And then for each piece, we go to the details of them and make them work. So that way it's, this kind of helping us to have a better design, which helps us to be more easier to change, easier to understand, easier to test, and all of those things. So that's what objects are and how we use them basically, and what is the benefit of them. Now, what is a class, right? We keep talking about the objects and the class, and then sometimes we don't know which one is what, right? So objects are the particular student I'm talking about, this student with this name and ID. But the class of students, right? The basic is kind of the template or the blueprint of those individual objects, right? So the student overall has particular state and particular behaviors, but then when each individual instance of that student class is going to have a name, right? John, for example, have a ID like 1, 2, 3, 4, 5. And so it's going to become more specific. So objects are the instance of basically classes. And so okay, so here we have this example, bicycle. And bicycle is our class bicycle. Like every bicycle gonna have some sort of speed and some sort of way to speed it up, for example. And we have my bicycle instance of type of bicycle, your bicycle instance of type of bicycle. And so basically those are these are the things that it's basically we need to know. So you see that one instance of bicycle, my bicycle, has a speed of 50. The other instance is your bicycle, and the speed of this one is 20. So you can call the behavior, the method, the speed up and increase the speed on this one, or maybe you have you don't have to call it, but whenever you call for your bicycle to call this speed up method of it, it's only going to see the 20 and it's going to either increase it or decrease it. That is going to only affect your bicycle. And if I go to my bicycle, I call the speed up method, it's only going to affect the speed of my bicycle. So when we're calling about instances, each instance has its own set of attributes, its own set of state basically, and its own set of behavior, and they're only going to have access to their own behaviors and their own data, right? So basically we call these data field, right? So my bicycle data field, the speed has 50 and your bicycle speed data field is 20. The data fields most of the time are instance. So that means they're going to be only available to my bicycle. If I'm inside my bicycle, I do have access to that instance. And if I'm in your bicycle, I do have access to your own speed. When we're showing them, this is how we show them in the UML diagram. So you see the UML diagram for class, it looks like a box. On the top of the box, it's going to be the name of your bicycle, which is the name of the class, right? And then you're going to see the second part of this box that's going to be listing all the data fields of bicycle. So bicycle is going to have a speed, it's going to have I don't know, gears, whatever the bicycle is going to have as an attribute, we're going to list all of them here. This is how we'll list them. So you see a negative number or negative symbol here. That means that this is a private member. Again, back to the information hiding, protecting our data. In order to do that, we need to make all of our data feed private. So that's a visibility. We're going to talk about the visibility modifiers or accessibility modifiers in next slide. But this is basically your visibility. And always, always, always keep that in mind. Always our data fields are going to be private. Their visibility is private. So that's why you see a negative symbol next to them, even in the UML diagram. Then they have a name, and then right in front of the name, you're going to type their type. So write their types, right? So they have this speed that is integer. And then this last box in the box of your class is going to have the behaviors. Most of the behaviors are going to be public behaviors because that's how you're going to interact with your bicycle. right? So you need to basically be able to have access to them. If you make them private, then nobody have access to it, right? So you need to make it public. So most of the time they're either public visibility, which you can see it with a plus next to them, or you may see package visibility or protected visibility. We're going to talk about those concepts. Then we'll see example of them. Here I'm just going to give you like overview of what other things you might see in the classes. But we also have what we call static members, right? So static members, you don't have to create instance in order to have access to them. Static members are belong to the class, not the instance, right? So they're not belong to objects. They belong to a class itself. So they're basically shared between all the objects. You can create 10 instances of bicycle, and if there is a static member, all of these bicycles going to have that exact same value. Those usually the static numbers are going to be uh, public because you have access to them everywhere. So they're usually public and they're usually also uh, final. So you see the public keyword next to them, you see final keyword next to them, and you see static keyword next to them. So they're coming usually together, but not always, but usually together, because if something is shared between all the instances, usually also it's read only, because you don't want these instances to make changes on it, right? So that's why you see the final keyword next to them. So final keyword, it makes a basically, if it's next to the variable, makes the variable to be a constant variable. That means it's a read-only variable. You cannot change it. So we're going to talk about this final keyword. We're going to see more example of a static member, but how we show them in this UML diagram. Static members are going to be shown by an underline, right? So basically, if I have a variable here, like number of bicycles, and it's going to keep counting how many bicycles I create, how many instances of these bicycles I create. Then I'm going to show it with a number of bicycles here in the data field, and it's going to be having an underline next, the line under it basically as you're writing this variable. So we see more examples in UML diagrams, so make it clear for you guys what and how we show the static members basically. So static members are going to have an underline, which here in this example, I don't have any static members. And then we ask you to draw the UML diagrams. You only going to show the class diagram. You're not showing our objects. So you see the difference between objects and the class. Objects, they have a name. When I create this instance of the bicycle, I called it my bicycle. How I created it, I said bicycle, my bicycle is equal to new, and then I call the constructor of the bicycle. And that's how I created this instance. Same thing for your bicycle. So we usually never ask you to draw objects in your diagrams. When we ask you to draw the class diagram, UML class diagram, we basically want you to draw your classes only. So you need a box, a template, or the basically prototype of that class, and all the attribute of the class and all the method of the class. Keep that in mind. I'm talking about data field attributes of the class, not the local variables. These are completely different from each other. Local variables belong to a particular method in your class. Like for example, inside a speed up, you have an integer type, you're doing something with it. But data fields belong to the class. They're inside the body of your class. They're not inside any of the methods, right? So that's a big difference between data fields and local variables. And I want you to completely understand that. So local variables are not coming to your class diagram. Whenever you draw your class diagram, you're only going to look for data fields. So I guess some of you, when you think about it, you in C++, maybe you're coming with the concepts of global variables, right? So there's no global variables really in Java. We don't have that concept. But the data fields are kind of like global to that class, right? So when I create in speed, I have access to this speed everywhere in this class. So it's kind of global to that class, right? But not to everywhere in your application, right? So just have, if you want to think about it that way, but it's really not the case, right? So we don't have that. That's what we call them data field. They're field of this particular class. So I'm going to stop this video and then we're going to continue by answering the question of what is inheritance.